I will be covering the final part of this three-part series on important quality terminologies everyone should know. This is a very useful input for every professional and more useful to those who are writing American Society for Quality Certification exams or project management certification exams. Please go through all these three series a few more times so that you consolidate this basic knowledge, which will become a good foundation for you to understand the further topics and become a highly quality focused professional, which is actually the expectation of future market, future customers. Hi, this is Jagdish Kumar, Master Black Belt, ASQ certified quality practitioner and lead auditor doing this presentation. Now let us understand customer satisfaction. Many people think they know, but they know only partially. Degree to which the customers are happy with the organization's products, very important. If the product is not good, then the company cannot do the business. Product should speak for itself. But product is not enough. There could be organizations who have services as their outputs, could be hotels or could be the software companies and so on. For them, it is important that they deliver an excellent service. But please remember, if I am manufacturing industry also, I cannot just focus on product alone and be contented. We should be able to give good customer services also, despite the product being excellent. There is a research in global scenario that people leave the company not for the quality of its products, because the services are poor from that company. So products alone will not lead to customer satisfaction. Please register this in mind. There is this particular research. And capability is very important. If there is an existing brand of motorcycle which is reputed and they release a new variant of motorbike, it is easily accepted in the market, as you can see. But whereas if a new startup company starts and releases a new motorbike, people will look at that with the suspicion, or it will take a longer time and more effort for the startup company to penetrate the market. This is the reason I think it is clear to you now. You should have all the three: products, services, and capabilities demonstrated, which are excellent. Now I'll give a brief on Six Sigma. Six Sigma is a product or an output of a process which has 3.44 defects per million opportunities. Means out of 1 million opportunity for defect, only 3.44 defects or less than that we can have. Or it is 99.9997% good. Please refer to this picture. In a Six Sigma process where the normal curve is anyway inevitable, the standard deviation is so low that it divides the specification region or the tolerance spread on one side into 6 equal parts. Or in other words, standard deviation is 1/6 the tolerance spread on one side. Then the process is called as a Six Sigma. In this case, as you can visualize, upper specification is here, lower specification is here, target values is here. The spread is so less that there is no possibility of any defect at all. The curve is not reaching even closer to the specification regions. This is a high quality world-class process. There are 3 streams of Six Sigma. One is DFSS, designed for Six Sigma, which follows 5 steps actually: define, measure, analyze, design, verify. These are structured approach to systematically arrive at a sustained solution. That's why we are compelled to follow these 5 steps: define, measure, analyze, design after analyzing and understanding the improvement requirements, and then verify the design. Verify the design we covered in the earlier. Second stream is manufacturing stream. DMAIC is followed: define, measure, analyze the difficulties, improve, then demonstrate and control. Means systematize, make it part of your document. Third variant is Lean Six Sigma. which you again uses define, measure, analyze, improve, control, because a structured approach can only give you the deeper and sustained solution, but here the objective is to eliminate waste. Waste we discussed in our volume 2. Now I'll come to metrology. Many people seem to understand, but let us have the precise knowledge. It is the science of precision measurement, minute measurement, where accuracy you will have challenges, and where you need accuracy. This becomes part of metrology. Metrology is a precision measurement, not every measurement. Please keep this in mind. Like using a vernier and taking very accurate dimension, or using micrometer and so on. Now I'll take up these two terminologies together, error and bias. As I take a reading from an instrument and note down, it may not be exactly matching with the true value. So for error, the difference between observed value and the true value is called as error, and it can be on plus side or it can be on the minus side of the true value. For example, as I measure 2 amperes, I may read 2.1 or I may read 1.9. So error can be on both sides. Bias, whereas, is the difference between average, the key word is average reading versus true value. Average of the readings by several individuals, or average of my own readings, say if I take 5 or 6 readings or even 10 readings and then take the average. What is the difference between that average reading and the true value is called as bias. Bias will never be on both the sides. For a given instrument, for its given deficiency, the bias will be always on one side of the true value. Please remember this from exam point of view also. If somebody is writing project management or ASQ or any other ISO certifications. Now I'll cover this statutory, legal and regulatory requirement, or even safety, which are subset of quality. We do compliance study, or the audit also is called as compliance audit, not conformance audit, whereas ISO is a conformance audit. Here statutory means I cannot do anything without adhering to that at all. I cannot. For example, a company cannot release a cigarette packet or packet of cigarette without the statutory requirement being fulfilled. That's cigarette causes cancer. Legal, it's a requirement which if you do not fulfill, you are straight away punished. There is even the first instance itself. Regulatory, it's a guideline, it is a recommendation, but it has to be adhered. If you do not adhere in the first instance, you will be given a warning and given one more opportunity to comply with. Safety is absence of hazard, which we covered already. How to ensure safety or compliance to the requirements is first have the latest, I'm telling again, latest issue of MSDS. What is MSDS? Material Safety Data Sheet, produced by and given by the supplier or the manufacturer. Study them and follow them. Never forget, for safety's sake, to provide adequate PPEs. These are all asked in the exams also or in interviews. PPEs, personal protective equipments. Now, there is a tool called as fault tree analysis for fault analysis, of course. It is like you can visualize like an organization chart. At the top, you write the top level failure. For example, computer fails, the personal computer fails. What are the reasons for which it can fail? I can write below, correct? Na? It may be CPU fails, monitor fails, mouse fails, or keyboard fails, and so on. So the PC can fail if item 1 fails, or item 2 fails, or item 3 fails, or item 4 fails. Given a form of an organization chart or a picture. A picture is worth 1,000 words, which will give much better idea to see the vulnerability and do an excellent reliability improvement. So this is fault tree analysis. I will explain this in detail as a separate subject. Then one more tool which is being commonly used, and it's a dire need, is quality function deployment. What is quality function deployment? Which is also called as a house of quality, because the inverted V here looks like the roof of the house. So here what we do is the customer's requirements are actually entered here, as you visualize, customers' requirements will be in qualitative terms. It cannot be straight away implemented. For example, in one company, we were making a raincoat for soldiers. Customer will say raincoat should be more leak proof. If I say this statement to a production person, he will be blinking. He will not be able to do anything at all. So there should be an interface, as you understood, since the customer requirement is qualitative, to convert that into a design parameter. For example, in this particular case of raincoat, increasing the cloth density is the way of improving the leak proofness. So I think you understood now. So QFD or quality function deployment is an excellent tool to convert the qualitative requirement of the customer into an implementable parameter by mapping it to the design specification. Also, QFD has an excellent provision of comparing with the competitors. So it's a great tool. I'll cover this separately as a session. There's one more tool called as FMEA. The full forms of all these and their utilities are asked in the interviews or even in the certification exams. FMEA is failure modes and effects analysis. Proactively, I do the risk management using a failure mode analysis table where I'll write in what all ways my product or my design can go bad. And after knowing the failure mode, I'll study the effects, because more severe effects have to be attended to, especially when it has a legal implication as well as a safety implication. So now I know the failure modes, I know the severity of effects. Now I'll map the failure causes. You can visualize it as an Excel sheet with so many tab columns. And I rate them for risk and they prioritize for improvement. I'll cover this in detail in one more session, because the strength of the chain is given by the strength of the weakest link. If there is some failure for which you have not taken a proactive action through risk management approach of FMEA, it can lead to a disaster. Because once the customer gets the negative impression, he will never come back. It takes seconds to lose the customer and years to build a customer. So that's where the risk management proactive approach of FMEA is very, very useful. Then there is a word FIFO, first in, first out. As you can visualize, first in, first out is practiced, say, in stores for shelf life items or items that may have a obsolescence. Because if I hold the shelf life item for longer and release the later received items, this may become out of shelf item, which only I may have to scrap. So that is why FIFO has to be followed. Please remember this word FIFO. Then there are very useful tools which are the recent phenomena like Scamper. Scamper is an excellent tool for designers, for innovators to come out with various options and ideas. As a designer, I should be a thinker, and when I am a thinker, there are two facets of thinking. One is deeper thinking, inches wide, miles deep. The other one is the lateral thinking. Look at various options and have an overview and take a decision. Now, Scamper actually supports your lateral thinking in developing a new product or a new service and so on. It is a lateral thinking technique and challenges status quo. Here you should say, why I am settling down with this? Why not improve it further? Why not better? Why not better? This should be the question that is coming in mind. Now, what does Scamper stand for is another question for interview or certification exams. S stands for substitute, C for combine, A for adapt, M for modify, P for put to another use, and E for eliminate, R for reverse. For example, substitute. Earlier car body was stainless steel, only 8 kilometers per liter was the mileage. Now it has been replaced by high grade plastics, composites, lightweight, sturdy, and mileage has now gone up, say 16 kilometer or 21 kilometer and so on. Substitute. Combine. Instead of doing one activity, do two activities. Simple example can be your pencil and eraser. You can write using the pencil. On the opposite end, there is an eraser which you can use to erase which we have written something wrongly. Combine. Adapt. Adapt the current product into a better product or into a new variant that can fit you the market. One example could be Coke to Diet Coke. That's an adaptation. Modify, magnify the reaction or magnify the action or minimize the action. Flywheel is a mechanical example here. Or using catalyst. I use negative catalyst to slow down the reaction, chemical reaction. Everyone would have studied this in chemistry. I use a positive catalyst to accelerate the reaction, that is modify. Put to another use. I have an item that is meant for using for a particular purpose. I use it for another purpose. For example, a software package that is used to capture the customer's identity. I can use it in a factory, I can use it also in a bank, and so on. There is one example that I saw somewhere in Ambala, that that particular Daba was using washing machine for making the lassi, to churn the buttermilk. So put to another use, maybe an innovation. Eliminate. Why use this item? Why not eliminate? This question is always asked by reliability engineers. Why I need this part? It's called a value analysis. If I find that part need not be used, I can remove that. This concept is called as part count reduction. By eliminating and having less number of parts in a system, the reliability goes up. That is the benefit. Tremendously it goes up. Eliminate. Reverse. Instead of doing the action in the forward direction, do it in the reverse direction. For example, generally we move the tool and make the part and give the part a required shape. But what happens in lathe? The tool is stationary, the job rotates, job moves. So this is a reversing the concept for quicker results and efficient, accurate results. Scamper, you please master this. This is an excellent tool. Scrum is another word. Scrum can be compared with Agile. Both sometimes get confused for the not so knowledgeable people. Agile is all about I do not have roles fixed for my team. As the events unfold, the roles are assigned, people do the job and maintain the timeline for a action which is a known. Whereas Scrum is a high-end complex scenario solving approach. Here, please read point number 1. It is a process framework. Why are we talking about framework? Scrum cannot be violating the company's rules, regulations and policies. It is within that framework they do. Every organization has its own policies, its own culture. Within that only we can work. So it's a process framework within which the people can address complex problems. As I told, compared to Agile, these are meant for high level complex problems to be addressed. Point number 3, for what? Develop and create products, or it can be services if I am in a say software industry. Develop and create products of highest value to customer. So what is the goal as far as Scrum is concerned? Solve complex issues within the company's policies and the procedures to create a product or a service that delivers the highest value to the customer, so that you are flourishing in your business. Next concept is benchmarking. What is benchmarking? Benchmarking is my process which I want to improve. I will compare with the process of another external group. Now that external group may be the group within my own company doing the same operation, say wave soldering, where I do wave soldering, how the other division that also makes wave soldering is doing better than me. I study them, I imbibe those good results, good approaches into my process and improve. This is called as internal benchmarking. Whereas I have a process, a debrazing, and I am comparing this process with how the best in the world is doing, learn and imbibe those into my process and improve. This is called as external benchmarking. Why benchmarking? Generally, when we set the target without benchmarking, we give a hypothetical target. There was a process where the highest yield, even the best in class in the world, has only 84%, whereas the company had a tendency to demand 98% yield, which could practically be never possible. So practicality aspect can be understood by using the benchmarking concept. That's why benchmarking concept is very, very important and is a current concept. Customer focus. Make efforts to understand customers' needs and expectation. This is one of the hallmark of a customer focused organization. Try to understand customers' needs and expectations. Needs may be told in your PO or explicitly by customers. Sometimes expectations may not be told, but you may have to capture and then deliver. But it is not just understanding. Point number 2 is more important. Strive to deliver the same, including your assurance to customer that you have excellent quality focus. Next is engagement of people. This also is a question mark. Many times in marriages we see engagement, isn't it? If you ask the youngsters what is the exact meaning of engagement, they may not be able to answer. So people are clear about their roles. Please remember all these points, 6 points. Roles, responsibilities, authorities. The people are clear in the organization and they are passionate to contribute. They have the mindset, they are motivated to contribute, and work is never a punishment to them, and do their best enthusiastically to meet organization's objectives. Finally, engagement of people should be towards fulfilling the organization's objective. That alignment should be there, and that can be done only by the leadership, isn't it? So engagement of people means people are clear about their roles, responsibilities, authorities. They are passionate to contribute. They do their best enthusiastically to meet organization's objectives. Please remember this. This is a question asked many times in many platforms. Next is APQP. APQP is nothing but Advanced Product Quality Planning. This is the current concept asked mainly mandatorily by global customers, and now great Indian companies are also asking for this. What is APQP? In simple words, it's quality planning right from designing the concept. I have to make a new product to my customer who is having his own requirements. I sit with the customer, capture the customer's requirement. From there, I develop the design concept. From then onwards, delivering the part to customer after successful approval. The entire span of activity is called as a advanced product quality planning. Now, for part approval, there is a subset of APQP, which is called as production part approval process. The full forms as well as the meanings of these are asked. Production part approval process is one quality plan I prepare, how I will check the product and ensure that the product is meeting all the requirements of the customer. Here the focus is only on the product and its inspection for approval. This also a mandatory document that I have to submit to the customer. APQP and PPAP. PPAP is a subset of APQP. Then every organization or every department, suppose tomorrow you are going as head of a department, you need to do what is called as SWOT analysis. What is SWOT analysis? Strength, weakness, opportunity, threat analysis. As you see, strength is positive, weakness is negative. If I take in pair, these are internal to the organization. Opportunity is positive, threat is negative, but these are external to the organization, in the environment, in the scenario, in the market, and so on. I will explain this in detail in the future topics. Then there is one more important thing to remember and to be understood, that is GEMBA. This is Japanese word. Gather details at the real place of action. Please remember, if you sit in our desk and start imagining, never you will see full reality. To know the full reality of your issues, problems, best way is to go to the place, do the detailed data collection. So GEMBA is a Japanese word which is very, very important. Improvement, when we talk about, there are two improvements actually, continuous improvement and continual improvement. You would have heard continual improvement now in ISO. Continuous improvement means I choose one parameter which I want to improve and keep on improving. But what can happen is after some time there is saturation. I may be doing enormous effort for a marginal gain. It may not be commercially viable. That's why now people look for continual improvement. What is continual improvement? Continual improvement is where I know where I am now. Say my yield is 68%. First time pass from the process is 68%. I fix where I have to go, say 84% or 85%. I can do benchmarking also, and I have a timeline. So continual improvement is where you know where you are, you know where you want to go, and there is a timeline. you improve in steps from 68 to 85%. This is continual improvement. Your quality objectives are examples of a continual improvement. Please remember the difference. Then there is what is called as gauge R&R, which is a mandatory requirement to be fulfilled for critical measurements, and data has to be submitted to the customers. Now, gauge repeatability and reproducibility is gauge RR. Repeatability means operator is same but he is measuring at different times. The reading should match. Reproducibility means the measurement may happen back to back, but not sharing the reading of course, but by different operators. So between people it is a reproducibility, from time to time it is a repeatability. But please remember, measurement system has 5 elements in it. This is a measurement system analysis tool called standard, according to which I am measuring. It may be NABL standard, it may be Indian standard, the workman, the instrument has an impact, the process of measurement has an impact, environment also has an impact. Like if I have to measure a resistance in 20 ohms at 20 degrees centigrade and I measure that at 25 degrees centigrade, good will get passed, rejected also sometimes, and bad will get passed. So this consequence can happen. Also please remember, calibration only checks the efficacy of the instrument. Calibration is not a replacement for a gauge R&R. Now I'll come to traceability. This also to be known very clearly. Maintain and control the unique identification, be it a serial number, be it a place where the item was assembled, where the item was inspected, which instrument was used, who did the inspection, and so on. Right from output side, the delivery or shipment side backwards till procurement of the goods and at inward goods stores. So maintain and control unique identification. Backwards is traceability. Forward sometimes is called as trackability. So backwards is the keyword here, backward from output side to inward side. For example, customer has a serious complaint, he gives me the model number and the serial number. I should be able to see when it was shipped, when it was tested, who did the testing, which machine equipments were used, where the assembly happened, when happened, and up to inward goods, which raw material was used, which batch, whether raw material was tested and found okay, and so on. Investigation also is required. Sometimes it becomes a serious investigation if you are making an aerospace part or a medical equipment part. Purpose is to ensure, and also important, we may have to demonstrate to customers or even to the legal bodies if it is a serious consequence that has happened because of our product. Ensure or demonstrate conformity of the product or service at all stages is the objective of traceability. This is also a commonly asked question. Traceability is backwards, objective. These things you should remember. Kappa is a common word used especially by global companies. Corrective and preventive action. Now, a fault occurred, I did the root cause analysis, I prepared a corrective action, I implemented, and that fault is not repeating in that product at all. But preventive action is also demanded by the customers. Means there may be 200 similar items I am making where this particular corrective action can benefit. Then I leverage that corrective action I learned and captured here into the other 200 similar products where also it can benefit. Leverage. This is called as a corrective action and a preventive action. A very useful methodology to be followed by every organization. Then there is a terminology called as process capability, process potential. I'll explain this as a separate topic, but just understand a process is said to have potential, means capability to make a particular item if the ratio of voice of customer divided by voice of process is more than 1 or at least equal to 1. Now what is voice of the customer? Voice of the customer is given by the tolerance spread for that particular item, means upper specification minus lower specification. Tolerance spread as given by the customer or as given by the designer on behalf of the customer. Tolerance spread divided by the process spread. Process spread is given by 6 times the standard deviation for the full normal curve. And this ratio should be equal to 1 or more than 1. This is an excellent measurement which is demanded by the customer before he finalizes the order on you for critical parameters. I take this opportunity again to request you to please subscribe to this channel and press the bell icon so that you get the notifications as and when we release successive very useful topics moving forward. If you have liked this presentation of covering the high level topics in simple way, please press the thumbs up and motivate us. Thank you so much for all your support.